So I tried to write out pretty much what we had on this oxygen saturation curve for both myoglobin and hemoglobin. And we're going to review it and get into the meat of what causes it in a moment. I want to start this video with a question for you to think about. Let me ask you this question over on the right. Take a look at the green curve, the sigmoidal curve for hemoglobin, and ask yourself, what partial pressure of oxygen causes there to be 3 oxygen bound to hemoglobin? Pause for a moment and see what you come up with. Okay, some of you might be puzzled by that. How do we know? Well, the answer comes from what I said earlier. Remember, hemoglobin has 4 binding sites. It's like a taxi with seats for 4 passengers. So if we have 3 oxygens bound to hemoglobin, that means we are at 75% saturation. So if we were to go over to here from 75% and then down, we would find that it's probably about 47 or so in terms of the answer. And don't forget, you got to have units. 47 torr, at least the way we drew it out on this particular picture. Okay, good. Now remember, we've rigged our oxygen saturation curves such that myoglobin wins. Myoglobin wins in the muscles. It comes away saturated while hemoglobin has lost its passengers and is unsaturated. This gap is critical, and we're going to continue to talk about that gap going forward. Notice we've got this funny situation. Hemoglobin is winning out here in the lungs, not against myoglobin. There is no myoglobin in the lungs. Hemoglobin is winning because it's 100% saturated or close to it, and it's losing out here in the muscles. The sigmoidal or S-shaped curve is what causes that. Winning over here, losing over here. How do you get an S-shaped curve? Well, here's the weird thing. If you have one oxygen binding to one protein, it must be hyperbolic. The only way to get it to be sigmoidal is to have more than one oxygen binding. And that's a really important principle called cooperative binding of oxygen. Let's go back up here and talk about it. When you have empty hemoglobin, the first oxygen to bind binds very weakly. However, once it binds, it helps or cooperates with another oxygen to bind, and that one binds a little bit less weakly. So we'll just say the second one binds weakly, not very weakly, but weakly. Those two help a third one bind, so maybe we would now say it binds tighter, the third one. And then the fourth one binds tightly. This progression from weaker to tighter is called cooperative binding. Let's see if we can visualize that down here on the curve below. Let's take a look at this curve. Let me ask you this. If we start here at 0 and move up in oxygen, how much increase in oxygen does it take to get to the first oxygen bound, and how much does it take to get to the second oxygen bound? How much increase from left to right does it take to get to the first, and how much does it take to get to the second? Let's make a note over here. First and second, how much oxygen bound? Pause it for a minute and see what you come up with. This is a very tricky question. Not everybody is going to follow this right away. But let's say, how much oxygen does it take to get to the first oxygen bound? Well, remember, the first oxygen bound is going to be 1 of 4, or 25%. And that is going to happen when we get to right about there. So if we were to look at how much we have gone across the x-axis, we would say, I don't know, I would guess it's going to be about 26 torr. Now, how much does it cost, or how much does it take to get to the 50% mark? Not as much. Maybe it only takes another 10 torr, let's say 36 or 38 torr, something like that. So you can see we had to put a lot of oxygen, 26 torr, to get the first one bound, but it went steeply up after that, and therefore it only took a lot less additional oxygen to get to the second one bound. The third one, very low as well, and then ultimately we tangent out at the top. But this is proof that a sigmoidal curve is progressively easier binding as we go. And that's what cooperativity is. So we're going to leave it at that for this video. And I'll tell you that in our next video, we're going to talk how do you get cooperativity, how do you get a sigmoidal curve from hemoglobin and not from myoglobin.